Okay, so this lesson is on section 8.1, the Pythagorean Theorem and its converse. I know you're pretty familiar with the Pythagorean Theorem. You've worked with that before, so this should be a pretty quick review. The Pythagorean Theorem is used to find the length of a side of a right triangle. Okay, and you probably already know the Pythagorean Theorem is a squared plus b squared is equal to c squared. Again, across the right angle is always the hypotenuse. And the two sides that make up the right angle are called the legs. Okay, and again, they're just showing it to you in words here. It does not matter which leg technically that you plug in for A and which leg you technically plug in for B. Okay, so let's go and get this moved up. So here we are, it's first just reviewing over what a Pythagorean triple is. A Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared is equal to c squared. So for example 1, it says, what is one common Pythagorean triple? And one most common one, my dad's in construction and he says that he uses this one all the time, is a 3, 4, 5 right triangle. Okay? The way that I know it's a Pythagorean triple is that they're all three whole numbers and it satisfies the Pythagorean theorem, meaning that if I plug the numbers into the Pythagorean theorem, that it gives me a true statement. If I have three numbers and I'm going to plug them in the Pythagorean theorem, then I have to make sure the biggest number goes in for c's place, because the hypotenuse is always going to be the biggest side of a right triangle. It doesn't matter if I put the 3 or 4 in for a or b. So 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, and that 5 squared then is 25. When I go and add my 9 and 16, I get 25 is equal to 25. And because that gives me a true statement, then yes, that satisfies the Pythagorean theorem. All three are whole numbers, so it's a Pythagorean triple. Any other multiples of 3, 4, and 5 would also be a Pythagorean triple. If I multiply all those by 2, and I get 6, 8, and 10, then I therefore know that that would also be a Pythagorean triple. But there are obviously other Pythagorean triples as well. That's just the most common one. On examples 2 and 3, they're saying to find the value of x and to simplify all radicals. So if I have a right triangle and I know two sides and I want to find the third side, that's where the Pythagorean theorem is going to come in. So I like to go ahead and write the formula that I'm using first. And from there, I can go ahead and plug my numbers in for a, b, and c. So I've got 20 squared plus 21 squared is equal to x squared. Okay? So again, I know that across the right angle is my hypotenuse, so I know that's what has to go in for c's place. The other two, again, it doesn't matter in for a or b. And when I go and work it out from there, I've got 400 plus 220 plus 441 is equal to x squared. When I go and add 400 and 441, I get 841. And when I take the square root of each side, then I get x is equal to, if you go ahead and type it in your calculator to see if it's a perfect square, in this case it is, and you get 29. If it's not a perfect square, then that's where you would need to simplify that down the radical, and we'll do that on the next one. Okay. All right, on the next one, again, we're plugging these numbers into the Pythagorean theorem. So again, I'm writing my Pythagorean, got my plus sign. So I'm going to write my Pythagorean theorem. Okay, again, figure out what your hypotenuse is first. Across the right angle is the hypotenuse. So 20 goes in for c's place, so therefore my 8 and my x are going to go in for a and b. Okay, and when I go ahead and start working that out, I know that 8 squared is 64. I know that 20 squared is 400. And from here, I need to get x squared by itself. So I can go and subtract 64 from both sides. And when I do that, I'm going to write the rest of it over here. So I get x squared is equal to 400 minus 64 gives you 336. From there, I know I need to take the square root of each side. Okay, and when I do that, I get x equals, if I try to put square root of 336 in my calculator, I do not get a perfect square. So I have to try and think of what perfect square goes evenly into 336. If you're having a hard time thinking of perfect squares, it's often helpful for people to write them. So if I go 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25. You could keep going forever. But these are what we call the perfect squares. So I'm trying to think of which one of these perfect squares goes evenly into 336. Okay, so again, a lot of times people will think of, if you think of the biggest one, you'll get there quicker. If you don't think of the biggest one, then you'll have to just simplify it down again. So let me just show you, probably a lot of people would say, oh, well 4 goes into 336. They might try that one with their calculator, 336 divided by 4, it goes in evenly. So they might say 4 times 84 gives me 336, okay? And that's fine, you know, the square root of 4 is 2. And I can't take the square root of 84, so I leave it as 84. But I always have to double check. It's kind of like a fraction that's not simplified all the way down. If there's a perfect square that goes evenly into 84, I need to do this process again. So in this particular case, I know that 4 also goes into 84. So I know it goes in 21 times, okay? So if that's the case, then I can take the square root of 4 and get 2. When I bring that 2 out in front, if there's something already there, then I have to multiply it, which becomes 4. And the square root of 21, I can't take the square root of, so it stays in the square root. So this is my simplified radical down, 4 square root of 21. If I had realized at the beginning that 16 went into 336, then I would have just gotten there quicker, okay? All right, let's go ahead and get that cleared. So next, if you look down at the bottom of this page, nothing really to, well, one thing to write down, but not much. So if you look at this, the converse of the Pythagorean theorem says if a squared plus b squared is equal to c squared, then the triangle is a right triangle. Okay? And so again, if it satisfies the Pythagorean theorem, then therefore it must be a right triangle. So we'll look at a couple of those. Okay, so if we look at that, it says, example 4, a triangle has side lengths 85, 84, and 13. Is the triangle a right triangle, and why? So in this case, again, write your Pythagorean theorem down. And again, we just want to see if that satisfies the Pythagorean theorem to know if it's a right triangle. If I look at my 3 numbers, again, I need to put the biggest one in for C's place. So the 84 squared plus 13 squared is equal to 85 squared. Again, it doesn't matter which I put in for A or B, but it does matter what I put in for C. Then I'm just working on both sides and seeing if I get a true statement. So in this case, I get 7,056 plus 169, which is 13 squared, is equal to 85 squared, which is 7,225. If I go and add these two up, I get 7,225. So since it equals out on both sides, then I know, yes, it satisfies the Pythagorean theorem, and if it satisfies the Pythagorean theorem, then yes, it's a right triangle. And so you can answer the question from there that yes, but it does say why. So you want to make sure that you put that into words and explain what you were doing there. And I said yes, if you plug the 2 smaller numbers, in for A and B, of the Pythagorean Theorem. And the largest number in for C you get a true statement. Okay, and that's one way to explain it. There's obviously other ways you could explain it as well. If I go and try example 5, again, same idea. I'm just plugging the numbers into the Pythagorean Theorem. I'm making sure that I'm putting the biggest number in for C's place. So I've got 16 squared plus 48 squared is equal to 50 squared. And from there, if I go ahead and do 16 squared, I've got 256 plus 2,304 is equal to 2,500. And if I go and add those two up, I get 2,560 is equal to 2,500, and I see that is not a true statement, so I'm going to put a slash to the equal sign to show that is not equal. Okay, and then from there I need to answer the question, and I can say no. And again, a different way that I could word this, I could say no, that 16, 48, and 50 do not satisfy the Pythagorean theorem. Okay, so that would be just another way to word my response. Okay. All right, let's go ahead and get that cleared and just a little bit more for this lesson. If we get this moved up, here is where you can determine what type of triangle it is based on the information given. So if a triangle is not a right triangle, then it can be either acute or obtuse. And what it's showing here is that if c squared is greater than a squared plus b squared, then it's obtuse. Okay, so again, if the hypotenuse side, if you square that, it's bigger than the a squared plus b squared side of the equation, then it's almost like the triangle is opened up even more, and so it's bigger than, this angle becomes bigger than 90, which therefore makes it an obtuse triangle. But if the c squared side is smaller than the a squared plus b squared side, it's like that angle is closed in some, it's less than 90, and therefore it's an acute triangle. So we can just take these numbers, plug them in the Pythagorean theorem, and if they're equal, we know it's a right triangle. If they aren't equal, depending on which side is bigger, we can know if it's an acute triangle or an obtuse triangle. So again, we're using the Pythagorean theorem. We're plugging the biggest number in for c's place. And again, we're just seeing what happens here. So if I go ahead and do 6 squared, I know that's 36. 11 squared is 121, and 14 squared is 196. And if I go ahead and add up these, I end up with 196. Oops. Actually, I'm looking at it wrong here. If I add up the 36 and the 121, I get 157. And this side is obviously still the 196. And I can see that, remember how the point goes to the smaller one and the alligator chomps the bigger one. So I can see the a squared plus b squared side is the smaller one, and the c squared side is the greater side. And that's what we said here. If the c squared side was the greater side, then it is obtuse. And they're asking us what kind of triangle it is. Okay. Same idea over here. We can plug these numbers in the Pythagorean theorem, make sure the biggest number goes in for c's place. So I've got 4 squared plus 5 squared is equal to 6 squared. If I work it out from there, I get that. And if I go and add up my 16 and my 25, I get 41. And in this case, I can see the c squared side is the smaller side, and the a squared side plus b squared side is the larger side. And so again, we said here, if the a squared plus b squared side is the larger side, then that is telling us that it is an acute triangle. Again, if they were equal, we would know it's a right triangle. Again, if you have any questions with this lesson, feel free to let me know, and I'll be glad to help you out.